M1 Abrams, birth of the American main battle tank. In the late 70s, the United States of America found itself in a humiliating position that was simply unthinkable for a superpower. A country that possessed the largest economy in the world and spent astronomical sums on defense suddenly discovered that its tank forces had fallen hopelessly behind its main adversary. While Soviet designers were releasing new combat vehicles one after another, American tankers continued to drive equipment created back during President Eisenhower's time. This was not just a technical problem, but a real strategic crisis that could cost America dearly in the event of a major war in Europe. The core of the American Army's tank fleet at that time was the M60 tank, adopted into service back in 1959. This machine was decent for its time, but that time had long since passed. Over 2 decades of operation, the tank underwent several modernizations, the last of which, with the Index A3, began entering the troops in 1978. However, all these improvements did not change the main thing. The foundation of the design remained the same 20-year-old tank with its outdated armor, old gun, and mediocre mobility. Meanwhile, on the other side of the Iron Curtain, very different things were happening. The Soviet Union did not stand still and consistently adopted more and more new machines. First appeared the T-62 with its smoothbore gun, then the revolutionary T-64 with an automatic loader, and then the mass-produced T-72, which began entering the troops by the thousands. Each of these tanks surpassed the American M60 in various parameters, and the Soviet industry churned them out in quantities that Americans could not even dream of. The most bitter part was that the Americans could have had a modern tank. In the 60s, together with West Germany, they were developing an ambitious project called the MBT-70. This machine was supposed to become a true breakthrough in tank construction. The designers incorporated a 152mm gun into it, capable not only of firing conventional shells, but also of launching guided anti-tank missiles through the barrel. No one else in the world had this, and the Americans and Germans expected to gain absolute superiority over any opponent. However, the ambitious project gradually turned into a nightmare for the military budget. The cost of development grew every year, and technical problems multiplied faster than engineers could solve them. By the early 70s, it became obvious that it would not be possible to bring this tank to serial production within a reasonable time frame, and then economic difficulties piled onto the United States. The Vietnam War was draining billions of dollars from the Treasury. Inflation was rising, and congressmen were increasingly reluctant to vote for costly military programs. In 1970, the Pentagon made a difficult decision and closed the MBT-70 program. Billions of dollars spent on development effectively went down the drain. The Americans tried to save at least something from this project and continued work on a simplified version of the tank, which received the designation XM-803. But this machine also proved to be too complex and expensive. At the end of 1971, it was also closed, finally burying hopes for a rapid rearmament. From this entire epic, the American Army received little. That very same 152mm gun, for the sake of which the entire project was started, did eventually go into use. True, it was placed on the same old M60, creating the A2 modification. But this version turned out to be so problematic that only 526 units were produced out of a total M60 run of over 15,000 machines. Another carrier of this gun was the Sheridan Light Amphibious Tank, intended for airborne troops. 1,700 units were produced, and it even managed to fight in Vietnam. But this machine could not be a replacement for the main tank. The situation was critical. Soviet tank armadas in Eastern Europe numbered tens of thousands of modern machines, and the Americans could only oppose them with outdated M60s. In the event of a large-scale war, these tanks were supposed to hold back the Soviet offensive on the territory of West Germany, and the generals in the Pentagon perfectly understood how that might end. Something had to be done urgently. And in February 1972, the chairman of the Joint Chiefs of Staff, Admiral Thomas Moorer, announced a competition to create a new main battle tank. American tank construction was receiving one last chance to prove that it was still capable of creating a world-class machine. Three major American corporations, each with rich experience in military contracts, applied for the competition. These were Ford, General Motors, and Chrysler, and each company proposed its own path toward creating a new tank. The struggle promised to be fierce, for a contract worth billions of dollars and the winner's prestige for decades to come were at stake. The Ford company went down the simplest and most logical path. Its engineers suggested not reinventing the wheel, but taking the existing West German Leopard 2 tank, which was undergoing testing at the time and showing excellent results, as a basis. The Germans had managed to create an excellent machine, and the Americans at Ford decided simply to adapt it to their needs. The main task in this process was translating all technical documentation from the metric system into the inch system, which the American industry traditionally used. It seemed like a reasonable solution. Why spend years on development if the Allies had already done everything for you? General Motors chose a completely different strategy. This corporation decided not to abandon the developments of the failed MBT-70 project and offered the Pentagon a further development of that same simplified XM-803 version, which had been closed just a few months before the competition was announced. The company's engineers were confident they could bring this machine to fruition by eliminating all the flaws that had ruined the original project. In essence, they were asking for a second chance and promised that this time everything would work out. The third participant in the competition, the Chrysler Corporation, presented a project that at first glance seemed the most risky. Instead of using proven solutions, Chrysler's designers proposed creating a fundamentally new machine with a revolutionary power plant. And it was this decision that ultimately determined the entire future fate of American tank construction. The heart of the Chrysler tank was to be the AGT 1500 gas turbine engine manufactured by the Lycoming Company. The history of this motor began back in 1964 when the Lycoming firm started its development in the hope of installing it on that same ill-fated MBT-70. However, the creators of the German-American tank had rejected the gas turbine at the time in favor of a more traditional diesel from the Continental Company. Now, this engine was getting a second chance. The gas turbine motor possessed several undeniable advantages. It developed 1,500 horsepower, which made it one of the most powerful tank engines in the world. At the same time, the turbine was remarkably versatile in terms of fuel. It could run on gasoline, diesel fuel, aviation kerosene, and even fuel oil. For an army that had to fight in many different corners of the planet, such flexibility was a very valuable quality. However, the gas turbine also had serious drawbacks that critics of the project did not tire of pointing out. The main one was a monstrous fuel consumption, on average double the appetite of a conventional diesel. For a country that had survived the 1973 oil crisis, this was a very significant argument against it. Furthermore, the gas turbine engine turned out to be unexpectedly heavy. At a mass of 3,850 kilograms, it weighed almost twice as much as the Continental diesel, which, with a power of only 25 horsepower less, had a mass of only 2,080 kilograms. The design peculiarities did not end there. A gas turbine engine by its nature does not need a gearbox unless it is a single-shaft type. The turbine itself is capable of smoothly changing torque over a wide range of revolutions. Nevertheless, Chrysler's designers, for some reason, equipped their tank with a hydromechanical transmission with a torque converter, the operation of which ate up about 10% of the engine's power. Why it was necessary to add this component was hard to understand, but the military accepted this decision without much objection. The evaluation of the submitted projects took several years. The military carefully studied each proposal, weighing all the pros and cons. The Ford project was rejected for reasons of national pride. The American Army could not drive German tanks, even if they were converted to inch sizes. The General Motors proposal was rejected for very understandable reasons. No one wanted to invest money in developing a project that had already failed twice. On November 12, 1976, the Pentagon announced the winner of the competition. It was the Chrysler Corporation with its gas turbine tank. Despite all the drawbacks of the proposed power plant, the military deemed that the advantages outweighed them. Power, multi-fuel capability, and the relative simplicity of the turbine's design won the debate against the diesel's efficiency. America placed its bet on a revolutionary solution, and now all that remained was to embody it in metal. The new tank was named in honor of General Crichton Abrams, who commanded American forces in Vietnam and held the post of Army Chief of Staff until his death in 1974. Ahead were years of intense work to refine the machine for serial production, and the designers were to solve many more complex technical tasks. Winning the competition was only the beginning of a long journey. Now, the Chrysler engineers faced the task that designers all over the world were struggling with: how to protect the tank from modern anti-tank weapons, which were becoming more lethal every year. Shaped charges burned through traditional steel armor like paper, and new sub-caliber projectiles pierced through thicknesses of metal that until recently seemed absolutely reliable. Fundamentally new solutions had to be sought. The answer was found on the other side of the Atlantic in a small English town called Chobham, located in the county of Surrey. It was there, at the research center of the British Ministry of Defense, that scientists developed a revolutionary type of armor, named after its birthplace. This armor was a complex, multi-layered construction in which different materials were combined in such a way as to resist many different types of threats. The Americans quickly realized that the British development was exactly what they needed for their new tank. An agreement was signed between the two countries on technology transfer, and a group of engineers from Chrysler went to England for a long-term internship. There, in that same town of Chobham, they grasped the intricacies of manufacturing this unusual armor, which was subsequently to protect American tankers on the battlefields. The structure of the new armor was striking in its complexity. The cheekbone packages, covering the most vulnerable parts of the turret, were a voluminous construction of many layers. In the front was a steel homogeneous armor plate, 63 5/10 millimeters thick, installed at an angle of 55 degrees to the vertical. Behind it followed an empty space more than half a meter wide, and then a rear armor plate 101 6/10 millimeters thick. But the main secret of the protection was hidden inside this space. There were packages of composite metal ceramic plates, 19 millimeters thick each, interleaved with 4 millimeter gaskets made of natural rubber. The composition of the ceramics included oxides and aluminum nitrate, barium titanate, and even corundum, which ranks second in hardness after diamond. Upon a projectile hit, this ceramic shattered, absorbing a huge amount of energy and distributing it over a large area. Between the composite packages and the rear armor plate was another protection element, designated by the abbreviation NERA, which stood for Non-Explosive Reactive Armor. It consisted of alternating 15 millimeter aluminum and 7 millimeter steel sheets with 4 millimeter rubber layers between them. Upon the impact of a shaped charge jet, these layers shifted relative to each other, disrupting the jet formation and significantly reducing its penetration capability. The lower front part of the hull had a similar structure, though with a smaller number of composite plates. The front armor plate there was thinner, only 31 7/75 millimeters. The turret sides also received multi-layer protection, but with an even thinner outer plate of 30 48 millimeters. But the upper front part of the hull, about whose thickness various rumors circulated, turned out to be surprisingly thin. Various publications cited figures of 76, 80, and even 125 millimeters, but the real thickness was only 38 and 1/10 millimeters. This part was saved from penetration only by a very sharp installation angle of 82.5 degrees to the vertical. At such an incline, even the fuses of anti-tank guided missiles did not have time to trigger, and sub-caliber shells either ricocheted or were forced to overcome almost 300 millimeters in the thickness of the metal. Parallel to the issues of armor, another important debate was being resolved. What gun to install on the new tank? The machine's creators initially proposed using the West German 120mm smoothbore gun manufactured by the Rheinmetall firm, the same one that was on the Leopard 2. However, the American military unexpectedly resisted this decision. Tankers insisted that the first series of the Abrams should receive the old 105mm rifled M68 gun, which was a licensed copy of the British L7 gun and was on all modifications of the M60. The main argument in favor of the smaller caliber was a larger ammunition load, 55 shells versus 40. Additionally, by the time the Abrams entered production, new armor-piercing sub-caliber shells with discarding sabots, first used on the M60A3 modification, were already ready for this gun. The Americans expected to compensate for the gun's lower power with higher firing accuracy thanks to a modern fire control system. Soviet tanks had automatic loaders providing a high rate of fire, but the American military was confident they could hit targets with the very first shot, not giving the enemy a chance to respond. On February 25, 1980, at a tank factory in the city of Lima, Ohio, an event occurred that the American Army had been waiting for almost 10 years. The first serial instance of the M1 Abrams tank came off the conveyor. The machine, which had traveled a long path from drawings to metal, finally found physical embodiment. American tank construction was entering a new era, and now it had to prove that all the years of development and billions of dollars spent were not in vain. The first serial Abramses were equipped with that very same 105mm M68 gun that the military had insisted upon. However, the ammunition for it was already quite different from what was used on the old M60S. By the start of production, based on the M735 armor-piercing sub-caliber shell, its improved M735A1 version had been created. The main difference of the new shell was the core material. Instead of tungsten, it used depleted uranium, the content of which reached 99 4/10%. Depleted uranium was a byproduct of uranium enrichment for nuclear power plants and nuclear weapons. In the United States, a huge amount of this material had accumulated, and the military found a very practical use for it. The density of depleted uranium significantly exceeded the density of tungsten, which gave the shell outstanding armor penetration. Furthermore, the uranium core possessed a unique self-sharpening property. When passing through armor, it did not flatten like tungsten, but maintained a sharp shape, which further increased its efficiency. However, uranium ammunition had a significant drawback that people preferred not to talk about. Depleted uranium was a weakly radioactive material, and long-term presence near it posed a certain danger to health. That is why the Abrams ammunition load was placed in a special niche in the rear part of the turret, separated from the inhabited compartment by an armored curtain. Officially, this curtain was intended to protect the crew from an explosion of the ammunition, but it also performed the function of a radiation shield, protecting the tankers from that negligible but, with prolonged exposure, dangerous radiation that the uranium shells emitted. Serial production of Abramses was gaining momentum, and it soon became obvious that the tank needed further improvement. In August 1984, after the production of 2,374 machines of the base modification, the M1A1 version was adopted into service. This version finally received that same 120mm Rheinmetall gun that the designers had proposed from the very beginning. The American military became convinced that firing accuracy alone was not enough and agreed to a more powerful gun, even at the cost of reducing the ammunition load to 40 shells. In addition to the new gun, the A1 modification received a collective protection system against weapons of mass destruction. The tank could now operate in conditions of nuclear, chemical, or biological contamination without exposing the crew to mortal danger. A pleasant addition to this system was an air conditioner, which in hot climates was far from a luxury but a necessity to maintain the crew's combat capability. All these improvements did not happen without leaving a trace on the machine's mass. If the first Abramses weighed 54,400 kilograms, the A1 modification grew heavier to 57,155 kilograms. The additional 3 tons required making changes to the chassis and developing a new track capable of withstanding the increased load. Furthermore, boron carbide was introduced into the composite armor's composition, giving the panels greater hardness, although seriously increasing their cost. Interestingly, parallel to the release of the A1 modification, production of tanks with the 105mm gun continued. These machines were produced until the end of May 1986 in an improved version, which was called Improved Performance. They received all the innovations of the A1 modification, including anti-nuclear protection and air conditioning, except for, naturally, the new gun. A total of 894 such tanks were produced. The introduction of the protection system against weapons of mass destruction led to an unexpected problem. The equipment took up part of the tank's internal volume, and the crew had nowhere to store personal belongings. The designers rightly feared that the tankers would start stacking their property directly on the roof of the turret's rear niche, where the blowout panels were located. These panels were supposed to fly outward in the event of an ammunition explosion, directing the shockwave away from the crew and giving the people a chance to survive. Additional weight on the panels could hinder their triggering and cost the tankers their lives. A simple and elegant solution was found. A special basket for personal items was welded to the rear of the turret. This element became the main external difference of the improved M1 from early series machines. The A1 modification was equipped with the same basket, only of a slightly larger size. In 1988, American engineers took the next step in perfecting the protection of their main tank. While previously depleted uranium was used only in ammunition, now they decided to apply it in armor as well. The idea was simple and elegant. The same material that so effectively pierced enemy protection could just as effectively resist enemy shells. Uranium armor represented a further development of the already familiar Chaubum-type construction. Inside the packages of metal ceramic panels appeared an additional layer of depleted uranium, lined with graphite to prevent corrosion and reduce the radiation background. Thanks to the abundance of this material, accumulated in the United States as a byproduct of nuclear power plant operations, the military could afford such a costly solution. However, far from all tanks were equipped with uranium armor. Machines with reinforced protection received the special designation M1A1HA, where the last 2 letters stood for heavy armor. These tanks were intended for units that were to operate in the most dangerous directions, where the likelihood of encountering the enemy's modern armored vehicles was highest. For the 120mm gun of the A1 modification, a new M829 shell with a solid uranium core was developed. The armor penetration of this ammunition, for the first time in the history of American tank construction, exceeded the indicators of Soviet shells contemporary to it. American tankers received a weapon capable of hitting any existing armored vehicle at distances previously considered unreachable. By the beginning of the 90s, the American Army possessed an entire family of combat vehicles based on the Abrams. The base M1 modification with a 105mm gun, the improved performance version with the same gun, but with anti-nuclear protection, the M1A1 modification with a 120mm gun, and finally, the variant with uranium armor. Each of these machines had its features, its strengths and weaknesses, but all of them represented a qualitative leap compared to the outdated M60S. The total production of tanks of the base modification was 2,374 units. 894 units of improved M1s with anti-nuclear protection were produced. The A1 modification was produced in even larger quantities. Moreover, some of these machines received uranium armor directly at the factory, and some were modernized later. The American industry was working at full capacity, saturating the troops with new equipment. 10 years had passed from the moment the first serial Abrams left the factory floor in Lima. During this time, the tank traveled the path from an experimental machine with an untested gas turbine to the foundation of the armored forces of the world's largest military power. Engineers eliminated childhood illnesses, the military refined application tactics, and industry established mass production of spare parts and ammunition. Throughout this time, Abramses served in Western Europe, preparing for a war that, fortunately, never began. Soviet tank armadas still stood on the other side of the Iron Curtain, but now the balance of power no longer looked so threatening. American tankers were confident in their machines and waited for an opportunity to test them in a real battle. Such an opportunity presented itself in August 1990 when Iraqi troops invaded Kuwait. The United States immediately began transferring its forces to the Persian Gulf, and along with infantry and aviation, tanks went there. For the first time in history, all 4 modifications of the Abrams existing at that moment were gathered together, ready to enter battle with an army equipped with Soviet technology. In January '91, an operation began that was to liberate Kuwait and demonstrate the power of American weapons to the whole world. The Abramses were to meet in battle with Iraqi T-55s, T-62s, and even T-72s, those very machines over which the Americans had so long tried to ensure superiority. The desert of the Arabian Peninsula was to become the arena for the first real test of a tank, born in the throes of failures and compromises, but which became a symbol of a new era of American tank construction. If you liked this story, give it a like and subscribe to the channel so as not to miss the next episode about the Abrams baptism of fire in the sands of the Persian Gulf. Write in the comments what other topics from the history of military technology you would be interested in learning about, and we will certainly tell you about them in future videos.